For the second problem, the object below is fixed on a fixed frictionless axle. It has moment of inertia of I, which is equal to 50 kilograms meter squared. So the forces acting on the object are the following. So we have F sub 1 equals 100 newtons, F sub 2 equals 200 newtons, and F sub 3 equals 250 newtons. And they are acting on different radii. So R sub 1 equals 60 centimeters, R sub 2 equals 42 centimeters, and R sub 3 equals 28 centimeters. So we are to find the angular acceleration of the object. Now you have to take note that since the axle is fixed, we only need to consider the torque. And then once we will obtain the torque, we will be able to get the angular acceleration. So recall that we have this equation, torque, summation of torques is equal to I alpha, which is analogous to Newton's second law of motion. So Newton's second law of motion states that summation of forces is equal to mass times acceleration. So this is for linear motion. So this is the rotational analog of Newton's second law of motion. So we have the summation of torques is equal to the moment of inertia multiplied by the angular acceleration. Now we have to take note also, or notice that all the forces F1, F2, and F3 are tangential with the object. Okay, so meaning to say your vector R is perpendicular with the forces. So we have torque is equal to R cross F. So this one is perpendicular with the force vector. Your vector R is perpendicular with your force vector, since uh, your force vector is tangential with respect to the object. So this is just equal to R times F sine. So if R and F are perpendicular with each other, then the angle between them is 90 degrees. So we have sine 90 degrees is equal to 1. Therefore, the torque is just equal to R times F. Okay. And then we will get each of the torques due to the three forces. Okay. And we also have to note that counterclockwise torques are positive and clockwise torques are negative. Okay, so for instance, you have here F1, which is directed there. So this causes a clockwise torque. So you have negative R sub 1, F sub 1, and then your F2 causes a positive torque. So you have plus R sub 2, F sub 2. Your F3 causes a positive torque also, counterclockwise direction. So you have R sub 3 multiplied by F sub 3. So we will equate this with I alpha. Okay, and then after this we can get alpha. So alpha is just equal to negative R sub 1 F sub 1 plus R sub 2 F sub 2 plus R sub 3 F sub 3 divided by the moment of inertia. So since all of these are given, we just have to substitute. So we have minus, your R sub 1 is 60 centimeters, so that is equivalent to 0.60 meter, multiplied by F1, which is 100 newtons, plus 42 centimeters converted to meter, that is 0.42 meter, multiplied by 200 newtons. And then you have R sub 3, so that is 0.28 meter multiplied by 250 newtons all over the moment of inertia of the system. So we have 50 kilogram meters squared. Okay, so evaluating this, we will get alpha, which is equal to about 1.88 radians per second squared. Okay, so this is the angular acceleration of the object.